We use the term work in everyday conversation to mean many different things. We talk about going to work, doing homework, or working in class. Physicists mean something very specific when they talk about work. In physics we use the term work to describe the process of transferring energy from object or system to another, or converting energy from one form to another. You will learn that work and energy are closely related to Newton's law of motion. You shall see that the energy of an object is its capacity to do work. And doing work is the process of transferring energy from one object to another, by means of a force. Work is the force causing the movement or displacement of an object. It is the scalar product of a force acting on an object, and the displacement caused by that force. This happens in the case of constant force. It has no direction, due to the nature of a scalar product, even though both force and displacement are vector quantities. The SI unit is joules. The equation for work is equal to force, multiplied to distance.
A train covers a distance of 15 kilometers and that the force is causing it to accelerate at a rate of 0.7 meters per second squared. Calculate the work done if the mass is 56,000 kilograms. Given the distance of 15 kilometers, convert it to meters. And the acceleration of 0.7 meters per second squared. First, we need to calculate the force. Force is equals to mass times acceleration. Mass of the train, which is 56,000 kilograms, times 0.7 meters per second squared. Force is equals to 39,200 Newton. We will attain work using this formula. Work is equals to force times distance. 39,200 Newton times 15,000 meter. Work is equals to 5.88 times 10 raised to the power of 8 joules. A boy uses a force of 30 newtons to lift his grocery bag while doing 60 joules of work. How far did he lift the grocery bags? Given the parameters of work equals to 60 joules and force equals to 30 newton. Work is equals to force times distance. Distance is equals to work over force. Substitute all the given parameters. Distance is equals to 60 joules or simply Newton meter over 30 Newton. Distance or displacement is equals to 2 meters.
Energy exists in many different forms. All forms of energy are either kinetic or potential energy. The energy associated with motion is called kinetic energy, while energy associated with position is called potential energy. Law of conservation of energy. Energy, as what we've noted, is conserved. Makes it one of the most important physical quantities in nature. The law of conservation of energy can be stated as follows: total energy is constant in any process. It may change in form or to be transferred from one system to another, but the total remains the same. We have explored some forms of energy and some ways it can be transferred from one system to another. This exploration led to the definition of two major types of energy: mechanical energy, Ka plus Pe, and energy transferred via work done by non-conservative forces, W&E. The equation for the conservation of energy is: initial kinetic energy plus initial potential energy is equal to final kinetic energy plus final potential energy.
A block is released from the top of the smooth inclined plane. What is the velocity of the block when hits the ground? Given the parameters of height equals to 5 meters and the formula of mechanical energy, kinetic energy initial plus potential energy initial equals to potential energy final plus kinetic energy final. We will cancel kinetic energy initial because it is not present on the block at the start. On the other side, we will also cancel potential energy final because only the kinetic energy final is present on the block while it's moving. Simplify. Potential energy initial equals to kinetic energy final. Potential energy initial is equals to mass times gravity times height, while kinetic energy final is equals to 1/2 mass times velocity squared. Cancel mass on both sides. Next, transpose 1/2 on the other side. It will become 2gh equals velocity squared. Next is put square root on both sides to cancel the square. Then, substitute the given. Velocity is equals to 9.90 meters per second. Object A and Object B have the same mass. Object A free fall from a height of h meters and Object B free fall from a height of 2h meters. If Object A hits the ground at v or velocity meter per second, then what is the kinetic energy of the Object B when it hits the ground? Solution: find the final velocity of Object B when free fall from a height of 2h. Using this formula, b squared is equals to 2g times 2h. Simplify. Simplify the following. v squared is equals to 4gh. The kinetic energy of Object B is equals to 1/2 mass times velocity squared. We will substitute the given value of velocity squared, which is 4gh. 1/2 mass times 4gh. Simplify the following. it will be 2 mgh. This will be our equation 1. The initial mechanical energy of object P is equals to kinetic energy. One-half mass times velocity squared. The principle of conservation of mechanical energy states that mgh is equals to 1/2 mv squared. Because mgh is equals to 1/2 mv squared, then we can change mgh in equation 1 with 1/2 mv squared. The kinetic energy of object B is 2 mgh as what we have earlier. Substitute mgh by 1/2 mv squared. Then, simplify the following. Cancel. The answer is mv squared.
Power is the rate of doing work or transferring heat. It is the amount of energy transferred or converted per unit of time. Having no direction, it is a scalar quantity. The unit of power is joule per second. The equation for finding power is power is equal to work divided by time.
You're riding a toboggan down an icy run to a frozen lake, and you accelerate the 80-kilogram combination of you and the toboggan from 1.0 meter per second to 2.0 meter per second in 2 seconds. How much power does that require? Given the parameters of mass, which is 80 kilograms, velocity initial, which is 1.0 meter per second, velocity final, 2.0 meter per second, and the time, which is 2.0 seconds. First, we will find work. Work is equals to 1/2 mass times velocity final squared minus 1/2 mass velocity initial squared. Substitute the given. Work is equals to 1/2 80 kilograms times 2.0 meters per second squared minus 1/2 80 kilograms times 1.0 meters per second squared. Work is equals to 120 joule. For the power, the formula is power equals to work over time. Substitute the following. Power is equals to 120 joule over 2.0 seconds. Power is equals to 60 watts. A 50-kilogram person runs up the stairs with 10 meters high in 2 minutes. Acceleration due to gravity is 9.8 meters per second squared. Determine the power. Given these parameters of mass equals to 50 kilograms, height 10 meters, acceleration due to gravity 9.8 meters per second squared, and time 2 minutes, or 120 seconds. We will first look for the work. Work is equals to mgh. Substitute the given. Work is equals to 50 kilograms times 9.8 times 10 meters. Work is equals to 4,905 joules. Now, we can solve for the power. Power is equals to work over time. Substitute. Power is equals to 4,905 joules over 120 seconds. Power is equals to 40.87 joule per second or 40.87 watts.